Chapter 5, Section 6 is about using the law of cosines. The equations for the law of cosines are based on a side and its corresponding angle. I'm going to put the equations in a little bit at a time to help you notice a few patterns. If I use side A and angle A, this is the start of the equation. If I use side B and angle B, our equation begins like this. Notice the equation begins with a side length squared and equals eventually the cosine of its corresponding angle. If I'm using a squared and ending with cosine of a, I will fill in the gaps with the other two side lengths, b and c. If I started with side b and ended with angle b, I will fill in the other gaps with the other two side lengths, a and c. If I use side c and angle c, think about how you would fill in the remaining pieces. There would be a -2 in the same location. The other two side lengths that have not been used are side lengths A and B. They would end up going here and here. Okay, so when can you use this formula? You can use it on any triangle. The triangle does not have to be a right triangle, although it can be a right triangle. You need to also be able to look at given information and decide if you should use the law of sines or the law of cosines. If you are given a side and its corresponding angle, you will immediately use the law of sines. If you are not given a side and its corresponding angle, then you should be using the law of cosines. You would use the law of cosines if you knew three sides, but more importantly, if you do not know a side and its corresponding angle, then you are using the law of cosines. We are going to go over a concept that you learned in geometry before we actually use the law of cosines. If you are given three side lengths of a triangle, you learned in geometry this property. To use this property, you add the two smaller sides together and just make sure that the answer to those two side lengths added together is bigger than the largest side. So in this case, I would add 2 and 3, and the sum of 2 and 3 would have to be larger than the largest side. 2 plus 3 is not larger than side length 6. Therefore, a triangle cannot be made with this information. The reason we are going over this property before using the law of cosines is in today's assignment, you will always be given three side lengths of a triangle. Before you jump in and start trying to find the three angle measures, you should look at this property. You want to add the two smaller side lengths and make sure that their sum is larger than the largest side. If it is not, then immediately you can say you cannot make a triangle, and then you're done with the problem. Here we are given three side lengths, and we want to solve the triangle. Before I start trying to find angle A, B, and C, I'm going to take the two smaller sides, 9.47 and 15.9, and add them together to make sure that their sum is larger than 21.1. Since their sum is larger than 21.1, I know that I have a triangle. Solve the triangle. We are given three sides, so we do not know a side and its corresponding angle. This tells us that we are going to use the law of cosines. We can find angle A, B, or C to begin with. For no particular reason, I'm going to go after angle C. If we want to find angle C, we will have the cosine of C, and then filling in the formula around it, if we have angle C, we will start the equation with side C squared equals, then A squared plus B squared minus 2 times AB. Okay, substituting in the values we know for the side lengths, we get this. Now we need to get cosine of C alone. But before I start moving things side to side, I'm going to do a little bit of simplifying. 21.1 squared is 449.44. 9.47 squared is 89.6809. 15.9 squared is 252.81, and 2 multiplied by 9.47 multiplied by 15.9 is the 301.146. All right, then I can combine 89.6809 with 252.81, giving me 342.4909. Now I'll start moving things to the side. Let's get rid of 342.4909 by subtracting it from both sides. Then we can divide both sides by negative 301.146. What's preventing angle C from being alone is the cosine, so we want to apply the inverse cosine to both sides. Make sure your calculator is in degree mode. When we take the inverse cosine of negative 0.3551404, we get 110.802 degrees. So we now know that angle C is 110.802 degrees. We now need to find either angle A or angle B. You might be tempted to use the law of sines because we now know side C and angle C. If you start a problem using law of cosines, do not go back to using the law of sines to find an angle. I will say that using the law of sines to find a side length is fine at any time if you have enough information. But again, never use the law of sines if you started the problem with the law of cosines. Okay, so we are going to find the next angle. I'm going to go with finding angle B. So I have the cosine of B. My equation will start with side B squared equals. Then we'll have A squared plus C squared minus 2AC. Substituting our known values, we get this. Before I start getting cosine of B alone, I'm going to take 15.9 and square it. Then I'm going to take 9.47 and square it and add it to 21.2 squared. Then I'm going to take negative 2 times 9.47 times 21.1, and I get this, and I still have the cosine of B. Moving things away from the cosine of B, I'm going to subtract 539.1209 from both sides. Then we'll divide both sides by negative 399.634. What's preventing angle B from being alone is the cosine, so we will apply the inverse cosine to both sides. Making sure your calculator is in degree mode, when I take the inverse cosine of 0.7164328, I get 44.2392554 degrees. Now that I know two angles, I can use those two angles and the fact that all triangles add up to 180 degrees to find the third missing angle. So 180 degrees minus angle B minus angle C, and we know that angle A is 24.96 degrees.